Okay, right. So, guys, from today we are going to discuss some serious calculation part. Yesterday we have seen child dose calculation. Today we will see isotonic calculations, displacement value calculations, and even if possible, allegation method of calculation. That is adjustment of percentages of alcohol. Right. In isotonic calculations, we need to know about the two types of isotonic calculations. Okay. అందులో number one will be the freeze point adjustment method, and number two, second method will be based on molecular concentration. Before understanding what is isotonic calculation, you should first be aware about the what is tonicity. Right. So what is isotonicity? It's very simple and everybody knows it. Right. It is like a measure of osmotic pressure, right? So if we are comparing our osmotic pressure of our formulation with that of the blood plasma, and if we find our formulation's osmotic pressure is high, then we are calling it hypertonic. And if the osmotic pressure of our formulation is low when compared to blood plasma, we are calling it hypotonic. So the work here is we will check whether our formulation is hypotonic or hypertonic. So this is what we are going to see. And the adjustment methods, in adjustment methods, we are going to see first what are the principles, general principles for calculation. Then we will do some example calculations. Okay. So let us see with the first general principle. You can see the solution for IV injections. There, this thing. What can we see? Their isotonicity is always desirable. So IV solutions of isotonicity should be equal to the blood plasma. So that should be careful. That would be first point. Solutions for IV injections. Then solutions for subcutaneous injection. This should be isotonicity is needed to be adjusted, and it's essential. They are injected into the fatty tissues and blood serum. So there should be isotonic to the muscles. Then I intramuscular injections, the aqueous solution should be slightly. Who's this? Okay. Hmm. Second phase, we will give her one. Ask her to come. Second phase, don't report. Hmm. Yeah. Yeah. No problem. No need, sir. Details there, we can. What is the reservation? SC, ST, BC. BCD बोलते सीट रोकना बोलते पेमेंट करना पड़ता, तो पैसे बने तो सीट रुक, मैं तो नहीं रुक। सेकंड फेज में सीट चले गए तो वी कांट handle. We will talk. We will talk. Ask her to call it 9 o'clock. Next, in intramuscular injections, also we need to adjust the tonicity. Right. So aqueous solution should be slightly hypotonic to promote the rapid absorption, because as we are giving the drug in muscles, the drug should be transferred or transported to the blood. So the solution should be hypertonic when you are giving the IM. And the intracutaneous injections, the parenteral preparations which are meant for the diagnostic purposes, should be isotonic in order to avoid the false reactions. And intrathecal injections, right, basically which are given in CSF fluid, cerebrospinal fluid, 60 to 80 ml is generally given. Hence, a small volume of paratonic solutions will distribute the osmotic pressure and may cause vomitings and other side effects. So you should be careful, and it should be isotonic. So in this case, IV should be isotonic, IM should be hypertonic, intracutaneous should be isotonic, and intrathecal should also be isotonic. Only one should be hypertonic, which is IM, intramuscular. That point should be noted. Then solution used for the nasal drops, especially, should also be isotonic, but they should be isotonic to the nasal secretions, not to the blood plasma. Then solutions used to the eye drops, like eye drops and eye lotions, they should be also isotonic, but they should be isotonic to the lacrimal secretions, right? And they should not be isotonic to the blood, because isotonicity of lacrimal secretions is different, nasal secretion is different, cerebrospinal fluid is different, and even your blood and plasma is different. So different body fluids will have the different amount of salts in them, different amounts of buffers in them, which is changing their isotonicity. So that should be kept in mind. Next, very important is dose adjustment using two methods in isotonicity. Please note it down. First method is using freeze point adjustment method. Very important. In what's happening in freeze point adjustment method, you can see here we are taking this formula. What we are doing, we are taking 0.52 minus A by B. So A is the freezing point of is freezing point of unadjusted solution, that is solution to be adjusted, that is our sample, and the B is freezing point of 1% weight by volume solution adjusting substance. The substance which we are adding to adjust the formulation is B. So these freezing points will be given in the question, and depending on other freezing points using this formula, we're going to solve the problem, right? So remember then what is 0.52? Any guesses? What is 0.52? This is freezing point of blood plasma. So hope you know the plasma contains almost 90% of water. So generally, because of presence of water, the plasma's freezing point should be zero because water's freezing point is zero. But presence of certain salts in the blood is changing the freezing point of the blood plasma. It is increasing from 0 to 0.52. You know, we already study the in like isotonic adjustments of normal saline solution. We take zero point 0.9 normal HCl, right? 0.9%. Why we are taking zero point 0.9 grams in 100 ml? Because zero point 0.9 grams of sodium chloride in 100 ml of water will make it isoosmotic to the blood plasma. And the minimum this amount of sodium chloride is bringing the osmotic pressure of the formulation, that is normal saline solution or dextrose infusion or DNS, to equal to the blood plasma's isotonicity. So 0.52 is the freezing point of blood plasma. A is the freezing point of the unadjusted solution, the solution which you are going to adjust. And B is the freezing point of 1% adjusting solution, the solution which you are adding to adjust the osmotic pressure of the substance. So please note the formula: 0.52 minus A by B, and everybody show me, open your camera and show me that you have noted this calculation. See guys, whether you are going to write MOH, Minister of Health exam in Dubai, Qatar, Riyadh, Oman, or wherever, whether you're going to write NAPLAX exam in USA, whether you're going to write any licensing exam, maybe in Australia, New Zealand, Canada, South Africa, or drug inspector exam, any exam, definitely they are going to ask questions from calculations. So this is very important. Tonicity calculation is most important. Definitely they are going to ask you calculation. So please note down the formula: 0.52 minus A by B. Remember what is 0.52? It's a freezing point of plasma. And what is A? It is a freezing point of unadjusted solution. What is B? Freezing point of 1% weight by volume adjusting solution. Please note it down. Show me on your screen. Then I'll go to the next formula and then we can go to calculations. Come on, Ruksar, Rajamani, Sivakrishna, Swati. Show your book. Show your book that you are noting this formula. Fast. We don't have time. Okay. So no one are listening to the class. Got it. Next. Next type of adjustment is molecular concentrations. This is the second formula. Here what we are taking the formula 0.03 into M by N. M stands for gram molecular weight of the substance, and N stands for number of ions it's going to be dissociated. For example, if I'm adding NaCl, NaCl can be broken down into two ions, Na plus and Cl minus. Depending on type of the compound, number of ions it can be dissociated into, N value is being noted, and gram molecular weight of substance gives us M value. Then we'll multiply it with the 0.03. This is the second formula with which we are going to adjust the freezing point. Okay, please note it down. Two formulae. Noting or not?
Yes, sir.
Thank you.
Completed, sir.
Yeah, thank you. Now, let's see the example. Everyone, please note down the question. Find the proportion of prochyne hydrochloride. Find the proportion of prochyne hydrochloride which will yield a solution isoosmotic to blood plasma. Ila istude question. We are going to calculate prochyne hydrochloride which will yield a solution isoosmotic with the blood plasma. So there certain values are given. You can see the value of B is given. What is that? B is freezing point of 1% weight by volume of existing solution. So the existing solution is here prochyne hydrochloride. So how much is freezing point? Minus 0.122 degrees centigrade. Apply the formula 0.52 minus A by B. 0.52 minus 0 by 0.122. Simplify this, you will get this 4.26 percentage weight by volume. So simply we are substituting it in the formula, right? Directly we are substituting it in the formula. And freezing point is given. కొన్ని freezing points మనం గుర్తుపెట్టుకోవాలండి. In next problem we will see example freezing point of sodium chloride మనకు గుర్తుండాలి. It's very important. Right? Simply we substitute it in the formula. Next question, see. Find the concentration of sodium chloride. Is asking concentration of sodium chloride required to make 1% solution of boric acid isoosmotic with the blood plasma. So given freezing point of 1% weight by volume solution of boric acid is 0.288 and the A value is 0.288. You are going to adjust the osmotic pressure of boric acid. And what you are going to use, you are going to use sodium chloride. So adjusting solution is sodium chloride. You are utilizing sodium chloride to adjust the isotonicity of the boric acid. So freezing point of boric acid will be A, freezing point of sodium chloride will be B, and the freezing point of the plasma will be 0.52. So what you will do? 0.52 minus A value ఏంటండి freezing point of boric acid ఎంత ఇచ్చాడు 0.288 by B value. What is B value? Freezing point of sodium chloride. ఇది గుర్తుపెట్టుకోవాలి. Sometimes they will not give in the question. 0.576 degrees centigrade. Freezing point of sodium chloride. This is the adjusting solution. 1% weight by volume of freezing point of sodium chloride is 0.576. So, e calculation రావాలంటే you need to remember just a formula 0.52 minus A by B. 0.52 is the freezing point of plasma. A is the freezing point of unadjusted solution, the solution which we are supposed to adjust in this equation, and B will be the freezing point of the sodium chloride. B value generally they will give. If it is most common one like sodium chloride, they will not give. You should remember it. It's a minus 0.576 degrees centigrade. Okay, I'm repeating the question for the people who haven't understood. The question is find the concentration of sodium chloride required to make 1% solution of boric acid isoosmotic with the blood plasma. Here, you are going to adjust the isoosmotic pressure of boric acid using sodium chloride 1% weight by volume. So, freezing point of 1% weight by volume of sodium chloride is minus 0.576 degrees. So the B value is 0.576 degrees. A value is given 0.288 degrees. That is freezing point of boric acid. So So you will substitute that in the formula 0.52 minus A by B. You will get the answer. You should select the answer from the option, that is 0.402% weight by volume. Okay, guys. Let's see the next question. If you understood it. Understood everybody? Shiva Krishna.
Sir, how should we know that one value
Yes? Sir, I
of
didn't get
A?
your question. How should
How
we
should
know
we
that?
know the value? No, which is value is A and which value is B, sir?
That's what I'm writing. Please write down. A is the freezing point of unadjusted solution. The question, in the question, he'll ask to adjust the osmotic pressure of certain eye drop. Example, atropine eye drop. So freezing point of atropine eye drop is A. And
Okay, sir.
with what solution you're going to adjust? Let's say you're going to adjust with the sodium chloride. So freezing point of sodium chloride will be B. In fact, this example is very worst example because we are not going to use sodium chloride in the eye drops. It will cause irritation. Still, I am giving you an example. B is that solution which you are adding in the formulation to adjust the osmotic pressure. A is the freezing point of that solution which you are supposed to adjust the osmotic pressure. So whatever your formulation you prepare, maybe the nasal drop, maybe the eye drop, maybe any injection, maybe any peritoneal solution, maybe any formulation which you prepared, its freezing point is A. Got it? And the substance which you are going to add to adjust the freezing point is B. The values of A, B will be given in the question. Sometimes they will give the value of A but will not give the value of B, because if it is so common one like sodium chloride, you should remember B value, that is freezing point of sodium chloride minus 0.576 degrees centigrade. Got it?
Yes, sir.
Swati, are you there? స్వాతి ఎక్కడ షాపింగ్ చేస్తాను
ఎస్
నీతో
సార్
ఆడే
నో
ఆఫర్లలో
సార్
నోట్
లేదు
చేసుకున్నావా
సార్ ఉన్నాను సార్ చేసుకున్నాను సార్
అండర్స్టూడ్ ద ప్రాబ్లం వెరీ సింపుల్ వన్
ఎస్ సార్
done
ఎస్ సార్
yeah let's see the next problem yeah so let me erase this so please note down the question or take a screenshot find concentration of sodium chloride right type of question change అయిందండి చూడండి find the concentration of sodium chloride required to make 1.5% solution of cocaine hydrochloride isosmotic to the blood plasma. So what is B here? Cocaine hydrochloride, because this is the solution what we prepared. So freezing point of cocaine hydrochloride is B here. Ruksar, got it?
Sir.
Yeah. Then freezing point of sodium chloride is A here. Sorry, extremely sorry. Freezing point of sodium chloride is B here because you are adjusting using sodium chloride. And the formulation which we prepared is cocaine hydrochloride. So this is B. So the freezing point of cocaine hydrochloride is B. Freezing point of sodium chloride. Sorry. Yeah, freezing point of sodium chloride is B. Freezing point of cocaine hydrochloride is A. Extremely sorry. Got it? See, the freezing point of 1% solution of cocaine hydrochloride is given. How much? 0.09 degrees centigrade. Freezing point of sodium chloride, if they don't give also, you should remember that is 0.576 degrees centigrade. Okay. In previous question also, we have seen the same thing. Now simply apply the formula 0.52 minus A by B. So A the slight change because here he is asking 1.5%. Generally, this is the freezing point of 1%. So we will change the formula into 0.52 into 0.09, that is freezing point of A, into 1.5 because this is of only 1%. So you are increasing it into 1.5%. Got it? See guys, the question asked here is, I'm repeating again, sodium chloride, concentration of sodium chloride and required to make 1.5% solution of cocaine hydrochloride. And generally the formula which we are using is for 1% only. If they are asking 1.5%, simply you are multiplying that 1% value with the 1.5%. That's it. So in formula 0.52 minus A value is freezing point of cocaine hydrochloride, that is 0.09, into you're adding 1.5, because in this question slight change, instead of 1% you ask 1.5%. That's it. And the B value is as usual 0.576. Okay Nandi, అర్థం కాకపోతే అడగండి. దిస్ స్లైట్ కన్ఫ్యూజన్ ఉంటుంది ఇక్కడ చూడండి. వాడు డైరెక్ట్ కాన్సన్ట్రేషన్ అడిగాడు. మన దగ్గర ఉన్న ఫార్ములా ఈస్ ఫర్ 1%. సో వీఆర్ మేకింగ్ ఇట్ ఇంటూ 1.5 by simply multiplying the A value with 1.5. So the formula here changed into 0.52 minus A by B kasta 0.52 minus A into 1.5 by 2 అయిపోయింది. Okay? Hello?
Okay, sir.
Yes? Got it guys? Yes?
Yes, sir.
Yeah, thank you. So let's see the next problem example. Find the concentration of sodium chloride to required to make 50 ml of isotonic solution. ఇక్కడ వాల్యూమ్ ఇచ్చాడు. Containing 0.5% ephedrine hydrochloride and 0.5% chlorobutanol. So given values, freezing point of 1% weight by volume solution of ephedrine hydrochloride is 0.165. Freezing point of 1% solution of chlorobutanol is 0.138. Now మీరు చెప్పండి ఇందులో ఏ వాల్యూ బి వాల్యూ ఏది? వాడు ఏమన్నాడు? కాన్సన్ట్రేషన్ ఆఫ్ సోడియం క్లోరైడ్ రిక్వైర్డ్ టు మేక్ isotonic solution containing 0.5% ephedrine hydrochloride and 0.5% chlorobutanol. So what is A value? What is B value here? See clearly here. Yeah. So as concentration of ephedrine hydrochloride in the formulation is 0.5% weight by volume, the depression in freezing point of ephedrine hydrochloride is ఇందాక ఇచ్చిన వాల్యూని మనం ఏం చేస్తున్నాం? చేంజ్ చేసుకుంటున్నాం. ఏంటిది? 0.165 freezing point is given for 1% weight by volume. సో దాన్ని 0.5 కి డిప్రిషియేట్ చేసుకుంటున్నాం. సో మల్టిప్లై చేస్తున్నాం. ఇందాక చేసాం కదా, A into 1.5 చేసాం కదా, ఇక్కడ వీఆర్ డూయింగ్ A into 0.5. Got it? ఓకేనా అండి? Next see. So the value we got after calculation is 0.0825 degrees. Next, as a concentration of chlorambutol also 0.5%. So freezing point of chlorambutol you are multiplying it with 0.5, because the freezing point which we got in the question is for 1% weight by volume, but here 0.5% is given. So ఇచ్చిన వాల్యూని ఫస్ట్ మనం డిడ్యూస్ చేసుకుంటున్నాం, తగ్గించుకుంటున్నాం, right? Depreciating the value. Then so total depression in the freezing point of the both the substances is, because in this case you are adding both A value లో you're adding both 0.025 కూడా ఉంది, 0.069 కూడా ఉంది. రెండింటిని యాడ్ చేసుకుంటే ఐఎమ్ గెటింగ్ దిస్ వాల్యూ, A value 0.1515. So here A is freezing point of ephedrine hydrochloride ప్లస్ ఫ్రీజింగ్ పాయింట్ ఆఫ్ ఇంకోటి ఏంటిదండి క్లోరమ్ బ్యూటనాల్. సో ఆ రెండింటిని కలిపి తయారు చేసిన ఫార్ములేషన్ ఇది. నా వాట్ ఈస్ బి హియర్? ఫ్రీజింగ్ పాయింట్ ఆఫ్ 1% వెయిట్ బై వాల్యూమ్ అడ్జస్టింగ్ సొల్యూషన్ కదా. అది ఎట్లా నేను గుర్తుపెట్టుకోవాలని చెప్పేంటి 0.576. ఈ క్వశ్చన్ లో ఇయ్యలేదు, బట్ స్టిల్ వీర్ adding it. So what we are doing 0.52 minus A by B. How we got A value? A value we got by freezing point of ephedrine hydrochloride plus freezing point of chlorine butanol, right? And direct freezing point తీసుకోలే మనం క్వశ్చన్ లో ఇచ్చినట్టు దట్ 0.165 ప్లస్ 0.0813 తీసుకోలేదు, దాన్ని డిప్రెస్ చేసాము ఇంతకి 0.5% కి. సి 1% వెయిట్ బై వాల్యూమ్ సొల్యూషన్ కాకుండా ఇందులో 0.5% వాడు ఎఫిడ్రిన్ హైడ్రోక్లోరైడ్ తీసుకున్నాడు, 0.5% క్లోరమ్ బ్యూటనాల్ తీసుకున్నాడు, 0.5% క్లోరమ్ బ్యూటనాల్ తీసుకున్నాడు. సో ఈ రెండింటి ఫ్రీజింగ్ పాయింట్ ని 0.5 తో మల్టిప్లై చేసి అడ్జస్ట్ చేశాను. ఆఫ్టర్ దట్ ఐ టుక్ దట్ వాల్యూ యాజ్ A. Then B value is the freezing point of sodium chloride. Clear? I am repeating this question for you. I understood that you didn't understand. So let's get back to the question. నేను అందుకే అండి ఆల్రెడీ క్వశ్చన్స్ అన్ని మీకు మార్నింగే పంపించేశాను. I hope you haven't seen those things in your group. I know this will happen with the students. See. So what is the question? Find the concentration of sodium chloride required to make 50 ml of isotonic solution containing 0% ephedrine hydrochloride, 0.5% chlorine butanol. అంటే A value లో freezing point of ephedrine hydrochloride plus freezing point of chlorine butanol తీసుకోవాలి. So మనకిచ్చిన freezing point is here 1% weight by volume solution of chlorine butanol and 1% weight by volume solution of ephedrine hydrochloride ఇచ్చాడు. So first the values we are depreciating. So what I am doing 0.156, I am multiplying it with 0.5. Then I am multiplying minus 0.138 into 0.5. Then our china values రెండింటిని I am adding it. Then I am getting A value. So our china A value ni I am adding it here 0.52 minus this A value which I got by adding the freezing point of chlorine butanol and freezing point of ephedrine hydrochloride after depreciation. Then I am adding B value, that is freezing point of sodium chloride. So depreciation లేదా appreciation value ఎలా calculate చేయాలి? Given percentage ని freezing point తో multiply చేస్తే సరిపోతుంది. So what is the given freezing point here? 0.565. See, question జాగ్రత్తగా చదవాలండి. See here what happened in the question, you can see here it's given 1% weight by volume solution. It's not given 0.5% weight by volume solution. మిమ్మల్ని ఎగ్జామ్ లో కన్ఫ్యూజ్ చేయడానికి వాడు ఇక్కడ డైరెక్ట్ గా 0.5% వెయిట్ బై వాల్యూమ్ సొల్యూషన్ ఇచ్చాడు అనుకోండి, నో నీడ్ టు డిప్రిషియేట్ ఇట్ అగైన్, యూ కెన్ డైరెక్ట్లీ యూజ్ దిస్ వాల్యూస్. గాట్ ఇట్? Yes, I people
Yes,
listening?
sir.
Yeah. So that's the important thing. Okawela if I am changing this question, instead of here 0.5% ephedrine, I am taking 1.5% ephedrine. What you will do? You will multiply this 0.165 with 1.5 because you are appreciating the value, increasing the freezing point to the level of the concentration given here. Okay, Nandi?
Yes, sir.
Right? You're checking this value and checking this value and adjusting those values. That is important in freeze point adjustment method. General ga idi chala easy calculation. You remembering very simple formula of 0.52 minus A by B will not going to help you. Practicing this is going to help you. 0.52 ఏంటి అని అడగొచ్చు. This is freezing point of plasma. A ఏంటిదని అడగొచ్చు. This is freezing point of solution to be adjusted. This is the freezing point of the formulation which you prepared. It may be eye drop, ear drop, nasal drop, any parenteral, any solution you prepared. B is the freezing point of that solution which you are adding to adjust the isotonicity. So we are going to check the given values and convert them depending on the percentages. Because if the given value is 1% and to be calculated is 0.5%, so freezing point is multiplied with that 0.5% to depreciate. If it is more, that is 1.5%, then we will multiply it with the 1.5%. That's what we discussed, right? So this is about the calculation of isotonicity. Let's jump into the next calculation. అర్థం కాకపోతే యూ రికార్డెడ్ వీడియో మళ్ళీ మళ్ళీ చూడండి. Calculation మీద definitely you're going to have one question in the exam. So this is what we have seen. This is what we have seen. You can see here, I'm multiplying the given freezing point with 0.5. Then I'm multiplying the other freezing point also. That one is chlorambutanol, one is ephedrine hydrochloride. Then I'm adjusting these two freezing points. Then I'm taking that value as A value. And the B value question lo ivvaledu. But I should know that sodium chloride freezing point is 0.576. అక్కడికి ప్రాబ్లం అయిపోలేదండి. వాడు 50 ml అన్నాడు కదా, ఇదంతా దేనికి 100 ml కి. సో 50 ml కి మళ్ళీ కొంచెం చేయాలి, రైట్? సి, సో weight of sodium chloride required for 100 ml solution is, this is what you got, this value, right? So for 50 ml, again this is divided by 2. So chala jagrataga, if you don't see the question, you're going to lose the mark. Got it? So 50 ml అన్నాడు కాబట్టి క్వశ్చన్ లో ఐఎమ్ రెడ్యూసింగ్ దిస్ 100 ml వచ్చిన ఆన్సర్ ని 50 ml కి తగ్గించుకుంటున్నాను. 100 ml ఇవ్వలే కదా సార్, హౌ కెన్ యూ సే 100 ml ఇవ్వకపోయినా పర్సెంట్ అంటే 100 ml? ఆ కామన్ సెన్స్ వాడాలి. గాట్ ఇట్? ఎస్. నెక్స్ట్ క్వశ్చన్. సి, నెక్స్ట్ ఈస్ ఫార్ములా చేంజ్ అయింది. నౌ ద క్వశ్చన్ ఈస్, హ్యావ్ ఎ లుక్, find the proportion of dextrose needed to form a solution isoosmotic with blood plasma. Nothing is given here, no freezing point. Then we'll wait, we'll use molecular weights, right? So what is the formula we are going to use? 0.03 into m by n, right? 0.03 into dextrose molecular weight is 180. అది minimum రావాలి మనకు ఎగ్జామ్ లో ఇవ్వకపోతే. By n value is 0 because dextrose is it's not ionic substance, it's not going to dissociate. So n value 0. So you will directly multiply 0.03 into gram molecular weight of dextrose, that is 180, will give me the answer, that is 5.4 grams per 100 ml of dextrose should be taken to make it isoosmotic to the blood plasma. Got it? This formula is so simple. 0.03 into m by n, as this is non-ionic substance, this cannot be dissociated. N value taken as 0. M value is the molecular weight of dextrose, 180 degrees. So 0.03 into 180 gave me the value 0.54. Got it? So this is how, when freezing points are not given, use the molecular weight. See the next problem. Same alane andi, using the molecular weights. Find the concentration of sodium chloride required to produce solution isoosmotic with the blood plasma. Calculate what is the molecular weight of sodium chloride. Ravali. Exam lo ivvadu. Molecular weight, gram molecular weight of sodium chloride is 58.5 gram molecular weight, right? And sodium chloride can be dissociated into two ions, Na plus and Cl minus. So M value is 58.5. N value is 2 because NaCl can be broken down into two ions, Na plus and Cl minus. So the formula is 0.03 into 58.5 by 2. Right? Got it? నోట్ చేయట్లేదండి మీరెవరు. So what will be the answer? 0.03 into 58.5 by 2. You will get 0.88 grams. Simplified. 0.03 into 58.5. Oh, మనమందరం బైపీసీ బ్యాక్గ్రౌండ్ కదా. వెరీ గుడ్. 0.03 into 58.5. You'll get 1.755. 1.755 divided by 2. You'll get 0.877. So round figure దాన్ని ఏం చేసుకుంటా 0.88. Okay. 0.033 into